Intrusion Detection Systems. An intranet is a highly secure private network, safeguarded by various networking devices. An intrusion detection system is commonly placed near the network perimeter, functioning as a passive system to scan incoming traffic, much like CCTV cameras above business entrances or sensors on doors. An intrusion detection system monitors network traffic and, upon identifying potentially harmful or suspicious activity, it sends alerts. However, it differs the action to an intrusion prevention system, which has the capability to actively block or prevent intrusions, distinguishing it from the intrusion detection system. An intrusion prevention system operates through inspection and investigation, which can involve signature-based and statistical anomaly-based methods. Inspection entails analyzing suspicious packets and activities, while investigation delves into their nature. Upon identification of unwelcome packets, the intrusion prevention system takes action by either quarantining them or dropping them altogether. Additionally, intrusion prevention system logs attacks and generates reports, similar to other security devices. Intrusion detection system and intrusion prevention system are not always distinct physical entities. They can be integrated into a single device along with other components like firewalls, routers, or proxies. Examples of such integrated systems include unified threat management and next-generation firewalls. Intrusion detection systems are designed to detect violations of their configurations and trigger alarms when an intrusion is detected, while intrusion prevention involves activities aimed at deterring intrusions. Intrusion detection and prevention systems are crucial components in safeguarding organizations against cyber threats. An intrusion, defined as an attacker's attempt to breach or disrupt an organization's information systems, prompts the need for effective prevention measures. Intrusion prevention involves activities aimed at deterring such breaches. Concurrently, intrusion detection relies on procedures and systems to swiftly identify any unauthorized access or disruptive activity within the system. Once an intrusion event is detected, intrusion reaction comes into play, encompassing the proactive actions undertaken by the organization to mitigate the threat and protect its assets. Intrusion detection and prevention systems encompass intrusion correction activities, which involve restoring operations to a normal state and identifying the source and method of intrusion. These systems detect configuration violations and trigger alarms, with many offering administrators the option to configure direct notifications via email or pages. Additionally, they can be set up to alert external security service organizations of detected breaches. In the realm of intrusion detection and prevention systems, two primary categories exist: network-based and host-based systems. Network-based intrusion detection and prevention systems concentrate on safeguarding network assets, with subsets such as wireless intrusion detection and prevention systems targeting wireless networks, while network behavior analysis (IDPSs) scrutinize traffic patterns to identify anomalies. A network-based intrusion detection and prevention system operates through a computer or appliance linked to a segment of an organization's network, actively seeking signs of potential attacks. By scrutinizing packets, it identifies attack patterns within network traffic, strategically placed within the network to monitor traffic entering and exiting specific segments effectively. Network intrusion detection and prevention systems offer several advantages, including the ability to effectively monitor expansive networks with minimal devices due to strategic placement and good network design. They are typically passive, allowing for seamless integration into existing networks without significant disruption to regular operations. However, network intrusion detection and prevention systems have drawbacks. They necessitate access to all monitored traffic and are unable to analyze encrypted packets, limiting their effectiveness in certain scenarios. Host-based intrusion detection and prevention systems are installed on individual computers or servers to exclusively monitor activities on that specific system. They benchmark and oversee the status of critical system files, detecting any unauthorized creation, modification, or deletion by intruders. Unlike network-based intrusion detection and prevention systems, they offer the advantage of accessing encrypted data traversing the network, enabling them to make informed decisions regarding potential or ongoing attacks. Typically, host-based IDPSs operate based on configuration or change management principles. Host-based intrusion detection and prevention systems offer several advantages. They can detect local events on host systems, uncovering attacks that might evade network-based intrusion detection and prevention systems. Operating directly on host systems, they have access to decrypted traffic for thorough processing, unlike network-based systems. Additionally, host-based intrusion detection and prevention systems remain unaffected by the use of switched network protocols. Moreover, they can identify irregularities in the utilization of applications and system programs by analyzing data stored in audit logs. Host-based intrusion detection and prevention systems come with several drawbacks. They are vulnerable to direct attacks and assaults on the host operating system, they fail to detect multi-host scanning, they are prone to certain denial-of-service attacks, and they can consume significant amounts of disk space. Signature-based detection, also known as knowledge-based detection or misuse detection, involves scrutinizing network traffic to identify patterns that correspond to known signatures, which is prevalent due to the distinct signatures of numerous attacks. However, a drawback of this method is the constant necessity of adding new attack patterns to the database of signatures within the intrusion detection and prevention system. Anomaly-based detection, also known as behavior-based detection, gathers statistical summaries by monitoring traffic deemed normal. When the observed activity deviates from established baseline parameters, the intrusion detection and prevention system issues an alert to the administrator, enabling the detection of novel attack types. However, this method demands significantly more overhead and processing capacity compared to signature-based detection, potentially leading to a higher occurrence of false positives. Stateful protocol analysis involves comparing known normal or benign protocol profiles with observed traffic. It stores and utilizes relevant data detected in a session to identify intrusions involving multiple requests or responses, enabling intrusion detection and prevention systems to better detect specialized, multi-session attacks. However, stateful protocol analysis comes with drawbacks including analytical complexity, heavy processing overhead, and the possibility of failing to detect intrusions unless the protocol violates fundamental behavior. Log file monitors analyze log files from servers, network devices, and even other intrusion detection and prevention systems to detect patterns and signatures indicative of attacks. This comprehensive approach, considering the entire network and its systems, often facilitates easier identification of attack patterns. However, implementing log file monitors demands significant resources for tasks such as collecting, transferring, storing, and analyzing extensive volumes of log data. An intrusion detection and prevention system can be deployed using one of three fundamental control strategies. In a centralized approach, all control functions are executed and overseen from a central location. Conversely, a fully distributed strategy entails implementing control functions at the physical site of each intrusion detection and prevention systems component. A partially distributed strategy combines elements of both, allowing individual agents to analyze and address local threats while reporting to a hierarchical central facility, facilitating the detection of widespread attacks across the organization. Centralized intrusion detection and prevention systems, fully distributed, and partially distributed control are three models of intrusion detection and prevention systems that vary in their architecture and management structure. National Institute of Standards and Technology recommends 4 locations for network intrusion detection and prevention system sensors: behind the external firewall in the network DMZ, outside an external firewall, on major network backbones, and on critical subnets. Thank you for watching.